Oh yeah.
Yeah, that's crunched. Both of them. Both intermediates. And the whole input gear is toast. Oh boy.
Yeah.
Hey look, I found where the teeth went.
One,
There's
2, 3, 4.
Woo!
Oh yeah. Oh.
Three, two, one, yeah!
Oh, moment of truth, yeah. If I can get this thing apart with my... with just me.
Got it.
There we go.
Oh yeah.
Crunched!
Oh yeah.
Yeah, that's crunched. Both of them. Both intermediates. And the whole input gear is toast. Oh boy.
Yeah.
Hey look, I found where the teeth went. There's the whole tooth right there. Oh, look at those little narrow teeth there.
Come out.
Oh yeah, they'll pop right out.
Oh, dude. So I actually don't think that the teeth were the problem. I think that you can kind of see
The main base body was the problem.
You see how it bent?
Yep.
All right. Well, can't say that we're surprised that this happened.
Yeah, on the narrow gears, kind of a thing. Yeah, this one's. We lost all the teeth.
Oh, is that bad?
Is that bad? Normally, I thought these were friction gears, where you just spin them real fast and they just melt together. Yeah, that's not good.
Yeah, dude. So I think what happened was, like, one of these started to go,
Yep.
and then once one got a little sideways.
I mean, the rest just eat.
You'll
And then
see-
as soon as one loses a tooth and other teeth start to contact each other at the same time,
yeah, and you'll
you
see,
end up with this, where all of them go together.
You'll see in the video too that when I actually stomped on it,
Yeah.
it was done already.
Yeah,
I
okay,
just gave it
okay.
a little goose, and it was just
Yeah.
like crunch.
Normally when I see failed gear teeth, I'm not used to pulling a bunch of full teeth out.
Yeah, well, it just speaks to the narrow gears have potential, but we need to actually design them correctly.
As opposed to what we did the first time, which was...
Well, maybe this is a good time for you to explain that. Why
Okay.
Why did this explode?
do we
Why are
have-
these gears narrow?
So when we designed this whole thing, obviously we did a bunch of math to make sure the gears were going to be strong enough, right? So we ended up deciding on our primary gearbox design uses 1.25 inch face width. So these are, you call them standard width gears that we expect will last however long we needed them to last and withstand all the forces we expect them to withstand. Math is great for a lot of things and helps us understand that, but empirical testing is obviously the best way to know that like our stuff is going to work. And when we went to set out, we kicked these ones off as our primary design. We also were like, we did all the math to know that this is going to be good. If we go thinner, does it actually show that thinner will fail earlier, right? So at the same time, we kicked off some narrow gears. So if you look at these together, you've got your standard one on top and your narrow set on the bottom.
So that the thicker one is what we're gonna go to production with, right?
Exactly. So this is what we expected. We wanted to go to production with, and we were like, can we go thinner? Can we make the portals narrower? Turns out the answer is no. We put these specifically in the rear axle to know that we expect higher loads as you're trying to climb things. When you're coming down stuff and you're loading up the front, it's not as big of a deal. So we put the thinner ones in the back because that should be our highest load case. And obviously, this one didn't make it.
And then what else do we have going on?
So we have 3 full sets, right, in total. We have our standard set, which is the 1.25" face width. We have these super narrow ones that you just saw that have failed. They were 3/4 inch face width. We also, in the right rear, have a 1 inch face width that's right in between. So those ones have yet to fail, and we're gonna pull that case apart soon and inspect it. But we know at minimum that we can't go down to a 3/4 inch face width, and we're gonna have to be thicker than that. Otherwise, you end up with teeth in your box that is sad.
So would you consider this a failure or a success?
This is a success. This is engineering learnings in real time.
Real life product development.
Yeah, exactly. So, I mean, yeah, that's kind of what we wanted to do, right? You want to prove out the math that we did that says we need a gear this thick, we need the portal to be this thick. Now we know we definitely can't go thinner. The math was correct that this will fail, but this has not. So we're going to continue to test on these ones, put a bunch more miles on them, and make sure that they are still good to go. But we fully expect that this should be perfect.
And I think maybe for me another takeaway is there is potential here that this could work if we don't have this groove for the super narrow ones.
Yep.
We basically just took the existing one and just said, okay, just remove this material, and we left this groove in here. And so maybe the teeth just were bending a little bit due to that groove.
Yeah. And we put this groove in here primarily for oil volume and oil moving around to make sure that we have enough space in the case for that. But then, yeah, when you move all the teeth to one side and you say, okay, put it all halfway on the groove, half of this tooth is above that groove. So it's easy for it to, bend over, snap one, and then the rest are toast.
Again, I'm pretty sure that's what happened because I was hearing some crunching well before.
Yeah, before you hit the gas and it went real loud bang, there was already some, Yeah, so it's for sure. You lost one tooth on here, and then as soon as that one was gone, it started to take the rest of them with it, and then it looks like the input gear lost all its teeth first before it got rid of the rest of these ones. But you see it on both of the intermediate gears too. You're not seeing it just on that because I just dropped some teeth in the case. You see it on both intermediate gears that they both failed in a similar fashion. If you're kind of looking in the groove here, this is bent in on most of them. But it looks like this is the one that really did it. You can kind of tell there when you zoom in that it's just, that tooth is not straight anymore.
Yeah.
So, failure analysis, success analysis. But yeah, for sure, this is a win for us to know what we can and can't do. Where the limit is. The limit is definitely higher than this. But seeing as how we haven't failed the other 1 inch gears yet, which we'll continue to wheel and find out. We haven't failed those. It means we may be somewhere in that 1 to 1.25" range. We're probably going to go to production with just the 1.25" just because we know it's going to be safe, and that's what we want for people, is nice and reliable. We learned stuff today. Woohoo!
Awesome.
Yeah.